Hey everyone. Hey Robert. How's everything going?
Hey, good. How are you?
I'm doing well. And thank you everyone for joining today. Welcome to the Keys to AWS Optimization. This is the show where we share concepts, solutions, and customer stories to help you unlock cost optimization on AWS. I'm John Massey, Principal Optimization Solutions Architect on the Optics team. And I'm joined today by Robert McCone, who is a Senior Efficient Compute Specialist Solutions Architect, who I've had the privilege of working with for past couple of years now, and really excited to have on the show for our episode today, talking about all types of things surrounding EC2 compute optimization. So, Robert, thanks so much for joining us today. Where are you joining the stream from?
Yeah, thanks for having me, John. I'm super excited. So I'm on the West Coast, sort of Central Coast, California, where it's bright and sunny and early in the morning.
Yeah, thank you so much for taking some time out of the morning to hop on here for our international audience of FinOps folks and cost optimization enthusiasts. So we definitely appreciate you taking the time to do that. I wanted to start by maybe talking a little bit about like compute optimization. Like, why is this so important to us? We're going to be kind of going into a couple of different areas, and I think the cool part about your background, Robert, is that you just see so many different customer workloads, so many different facets of optimization and what that means to different folks. But like in preparation for this, was looking at some of those stats around EC2, and we all know that this is central to the majority of workloads that we're running, on AWS. But since EC2 launched in 2006, more than 30 billion instances have been launched. And the interesting part about that is that of that 30 billion, it took 2.5 years just to launch the first million instances. And since then, more than 100 million instances are being launched on a daily basis right now. So that's a statistic from last December at reInvent. So may have gone up, but just that is, I think, a pretty staggering amount of compute workloads to be launching.
Absolutely. I mean, that's 30 billion, billion with a B. That's big.
Billion with a B, exactly. Yeah, I mean, almost hard to sort of wrap your head around that scale. And I think what was really cool about that, I know a lot of folks are getting excited for reInvent this year. It's still worthwhile, I think, to go back and look at some of the compute tracks that happened last year at reInvent, because there were still so many announcements that came out, things about Graviton and EKS and all kinds of cool areas to dive into. So it's a good kind of refresher going into reInvent for this year.
Yeah, absolutely.
So just to ask a question to our audience as we're getting started here, I'm curious, from the folks that are joining our call today or joining our stream today, are any of you out there planning compute optimizations for your workloads aside from things like idle and right sizing actions? So in the chat, go through and put a yes as a number one, and if no, put a number two in the chat for us. I hope I got that right there. But okay, cool. So I think we're going to have a great talk track for ourselves, Robert, to introduce some like new concepts to folks, and really excited to, maybe we're already piquing interest as I start to see that tally start to grow in front of us. Maybe more and more folks are going to be planning those compute optimizations in some of these new areas as they hear what we've got to share.
Yeah, there were some quick answers for the no. There's a lot of people knew absolutely where they were going.
Yeah, exactly. And I think what's interesting, and maybe something that we're starting to see from the conversations that I've been able to join of yours, is that different audiences are maybe prioritizing those in different places. So some of the folks maybe are looking at that as just like an architectural decision for like net new greenfield workloads, and maybe not so much thinking about some of those more architectural centric changes as being optimization patterns, but there'll be big factors as far as efficiency goes, at least with like customers' overall EC2 footprint over the next year. Mm-hmm. We're kind of getting a little bit ahead of ourselves too. Want to maybe just slow down for a second and talking a little bit about some of the stuff that we've done together. Robert, maybe you want to give us your 1-minute origin story and a little bit of background. How'd you get to AWS? What type of work are you doing? Just let us know a little bit more about you.
Sure. Yeah. Let's see. 1 minute. Let's condense this. So
You go more than that too. So
Could go a little bit over. We'll see.
yeah,
I think I can keep it to a minute. So I started my journey a little over 15 years ago, actually. So building and running data centers for some of Adobe's SaaS products. Uh, One of the really exciting things that I was able to do during that time was I was part of a small team that actually we built a private cloud internally. So that was a super exciting thing to do. After that, I ended up bouncing around a lot to a bunch of different companies and startups, uh, doing a bunch of different programming projects, from apps to pages to data visualizations to even computational biology. And I always found myself not just doing that core piece, but helping those companies either migrate to the cloud or build further on the cloud. So throughout all that, I eventually made my way to AWS, where effectively the cloud began, and I've been here for about 2.5 years. And as you mentioned earlier, introducing me, I'm an efficient compute specialist, and I have a really cool job. John and I work really close together. I get to help customers save money on their EC2 spend by architecting for best practices. It's a really really cool thing that I get to do, and I'm loving every moment of it.
it's awesome. And I think one of the cool things I learn from you every time I see you driving customer conversations or helping to ramp up folks on the AWS side is that there's not just one path forward, right? We're talking about compute workloads that have so many different facets to them, so many different, components and kind of variables. Figuring out what's the right compute optimization path for a customer, it may not be the same as the last customer conversation, and it changes very quickly as new capabilities, new features are coming out, things are being made available. So it's always fun surprises and always something new, to learn in this space. I think it's one of the probably fastest moving areas, within AWS, just 'cause there's so many different workloads, 30 billion, instances being deployed. We've got 700 different instance types now. I mean, keep me honest, I think it's maybe a little bit
So
more than,
it's
yeah.
over 750 now, as far as, yeah, and more than that at this point. Yeah.
Yeah. And a lot of options that are available for, um, really being able to dial this in for specific workloads.
Mhm.
So I thought maybe a good place for us to start. Now that we've got your background and you've shared a little bit about what you're doing, maybe we could just talk a little bit about why optimization is important for EC2 workloads. Yeah, I'd love to kind of hear your perspective. Like what types of things are folks coming to you with, and what are you kind of hearing from the field right now?
Yeah. So optimization, from my point of view, is super important. I mean, one, the big reason to optimize is to save on spend, right? We want you running your workloads on AWS, specifically EC2 is what I cover, but we also want you to do it in an optimized way. And the reason for that is, if you optimize your workload, you're able to shift those resources to focus more on your core business, to innovate throughout your own company, and in turn, try new things, launch new things. So the more you optimize your workload, the more you're able to do more for your own business, your own company, and so on. And the more you're going to grow, which is good for us and it's good for you. It's sort of a win-win.
Yeah, and definitely win-win. Helps folks start to scale, helps them start to grow, and helps drive more performance too. I think that's one of the other cool parts too. A lot of times when we think of efficiency, I hear from customers sometimes that maybe there's a little bit of a preconceived notion that driving down cost is going to also have some sort of compromise when it comes to performance, which really is not the case for all situations. There's a lot of cases where we can reduce cost while also delivering more performance or run workloads faster. And I think that's a really cool part about it as well.
Yeah, that's a really really good point. The idea that you're always spending and you get X amount for that. With over 750 instance types, for one, there's different instance types. Your dollar is going to go further for your particular workload, whether you're on one instance type or another. in some cases, right? There's a lot of options. I'm gonna get ahead of ourselves a little bit here, but there's Graviton instances, there's Spot instances, there's Elasticity, which I hope we can dive into. There's a lot of options for actually saving and optimizing your workloads without cutting any kind of performance. And in fact, uh, there's ways of gaining performance by doing optimization. So it's not a case of picking one over the other. It's really the case of spending the time and optimizing both.
So that's a good point. Let's talk a little bit about what some of those different workload patterns are. We started this by asking a little bit about things like right sizing or looking at idle resources. Maybe help the audience, kind of walk through and hear a little bit about like the difference between workloads that maybe are looking at horizontal scaling versus ones that have vertical scaling, where right sizing maybe plays a bigger role in that. And then maybe the second area that we were thinking about was like containerized workloads versus ones that are just running directly on EC2 instances themselves. Like, could you help kind of paint a picture of what some of these like different patterns are when it comes to EC2 workloads?
Yeah, absolutely. So vertical scaling and horizontal scaling is pretty straightforward. Vertical scaling is where you add compute resources or remove compute resources to an instance. This is right sizing. This is what a lot of folks are familiar with when they want to when they're worried about underutilized uh, compute. They might just look to right size to lower an instance, or if they need more performance, they might increase that instance size. Horizontal scaling is where you actually distribute your workload across multiple nodes. So you scale out to meet workload demand and then scale in when you don't need it anymore, rather than building up vertically. The thing with vertical scaling, while you want to optimize and right size those instances as a first step, you can only get so big on an instance, and you can only get you can't go beyond that. And it's not something that's super reactive in general. It's you right size an instance, you're good to go, you're running your workload on it. With horizontal scaling, you've got the elasticity of the cloud that you can work with. You can scale out to meet demand as large as you need, and then scale back in when that demand is gone. And really, like, if I can really double down on that elasticity component, that really is the promise of the cloud. It really embodies the pay as you go, on demand, only use what you need benefit of moving from an on-prem workload to the cloud. And so there's a phrase that I like to use. It's kind of a silly phrase. It's an obvious phrase, but it really is something that gets overlooked when folks are running on the cloud. Even seasoned customers sometimes aren't leaning into elasticity. You can right size all you want, but the most cost optimized instance that you can ever have is the one that you don't run. It's a silly phrase, but it really drives home. If you're not using that elasticity of the cloud effectively, you're leaving a lot on the table. You're really not leveraging the cloud to its full potential. So horizontal scaling tends to be where you want to end up. You want to be scaling horizontally to match that workload, whether you're in a containerized workload or not. You want to be able to basically scale out to meet real-time demand, but then when that demand's gone, you want to scale back in so that you're saving money.
Yeah, one of the things that comes to mind right now, like as you're talking about that, is that sometimes those phrases, right, like being able to keep that in mind, is just a great reminder. Like keep it simple. And then we also see that there are cases where that there's an instance that maybe looks like it's idle, and someone says, "Hey, can we just delete this? Can we remove this?" And they don't realize that maybe the reason why it's idle is because it is part of a horizontal scaling workload, and maybe there's some allocation strategy in place that's spreading this across multiple AZs, and it's not just something that's left there; it's by design. It's something
Yep.
that's running there, and maybe you can reevaluate that and say, "Hey, do I need this or not?" Or is it part of the scaling for a workload where the floor is maybe set too high on scaling for that, and you've got unused instances that you don't need, but not quite as simple as just sort of like a lone idle instance that's something forgotten about. It could be part of a broader design decision. And those are tough patterns, I think, for folks to be able to sort of pin down and get to the bottom of.
Yeah, definitely. And they're tough because there can be a lot of moving components, as you mentioned. uh, your example was great. The having an instance, it might be idle or underutilized, but it might be there because it's in another availability zone for resiliency. So even when you're optimizing for performance, for cost, you're also juggling a couple other things, such as high availability. You want to make sure you might have a base layer to meet SLAs. There's a lot of moving parts. It can be overwhelming, so it can be tough to really optimize, to your point, without knowing why those decisions are being made. And thankfully, there's a lot of tools like allocation strategies, that you brought up, that help. And auto scaling groups are a really powerful way to provision workloads on EC2 that help with a lot of these things. They spread out over AZs for you. They keep it balanced. You can leverage those allocation strategies. You sort of define what your needs are, and the auto scaling group can take control for you. It'll even scale out, so we can get to scaling, but I don't want to get too far ahead of us, but with auto scaling groups, you can define your target, sort of a proxy measure of what your workload needs. Usually CPU utilization. There's others that can be done. We can dive deep into that if we want to. If folks on the call have particular questions or want to dive deep into it. But generally, CPU utilization gets used to scale out and aggregate, and then back in when it's not needed anymore.
And I think that's probably you didn't see the questions coming through, but spot on. We had one that came through. It says, what's a good algorithm to use detecting when to add instances and when to remove instances for horizontal scaling? And the question mentions, collecting the metrics like CPU, RAM, network. But yeah, what do you think, Robert?
So the engineer's favorite answer here is always it depends, right? So that's the real answer, but there's some generalities and there's some guidance that I can give here. You do want to start with your workload and work back and see what's important. So for most workloads, it could be transactions. If it's a web service, it could be transactions per second. You might have an SLA that you need to hit, so you need to keep latency in mind. Figure out what makes sense for that workload. What are you really trying to target? In general, the metrics that were being measured with the example, CPU, RAM, network, those are the most used metrics for those for scaling. CPU utilization being the biggest one, aggregate CPU across your fleet. But sometimes memory can be used, sometimes network, and you can use custom metrics to blend them together if you might have multiple bottlenecks and you want to make sure you scale at whichever one happens to hit that bottleneck first. You can scale up from that. Uh, kind of part of the answer to that was you can use a custom metric to blend those, but what you want to do is make sure you're doing it based on your workload. Figure out what's important for that workload. Another metric that wasn't mentioned that could depend on the workload is some customers that will use queue depth. So they'll have SQS workers, and they'll use queue depth to scale out because they want to hit a certain SLA. They have a certain SLA for delivering, a job within a certain amount of time. So as that queue depth grows, they want to scale out so that they can make sure they actually hit that. So there's a lot of different ways you can scale, a lot of different metrics you can use, but CPU, memory, network, those are definitely the big three. You're already on that. If you want to develop your own algorithm, that's custom metrics, use that. But in general, using something like target tracking is going to cover most workloads. It's kind of like a thermostat approach. You say, hey, target this, say 60% CPU utilization, and the auto scaling group will scale out automatically to meet that. It'll scale out, scale back down as it needs to. If you need to get a little bit more, and you can use custom metrics with that. So that's going to be a good general approach.
So that like it depends answer that comes back. Like I'm curious your thoughts on like testing methodologies, right? So you're talking about like the target tracking, maybe having some instrumentation that's pulling out some of these more like app level metrics. Like could you share maybe a couple thoughts on like what's a good testing methodology? How do you make it better? How do you evaluate? How do you know if what you're doing is good? What have you seen that's been working well for folks out there?
Yeah. So great question. And this is there's pretty solid methodologies to this. It starts off with just defining what matters for your workload. Again, if it's transactions per second, or since we're optimizing here, it'd be transactions per second per dollar, right? You want to get more transactions per second for your spend on EC2. But it could be transactions per second, it could be latency, it could be number of concurrent workloads being served, whatever it might happen to be. You want to start with that. Define what matters, and then define any kind of SLAs or SLOs that you have, your minimum requirements. Okay, we have to hit these, or if you have a 95% SLA or something like that, define those workload requirements, and then start off doing a little test, basically, and test with your real world workload, or simulate your actual workload rather than doing benchmarks. Grab some instances, and actually deploy to those instances, and just do a little test. Push those instances. In fact, you want to see where they break. You don't want to just say run a workload, say, okay, it works on this, we're good to go. You want to actually push those instances until they fail, until they break the latency, until they can't handle anymore, so that you know where the limits are, so that you can set your thresholds for scaling. So you want to set your scaling thresholds before whatever instances you end up picking up will break. Gather all those metrics, right? So that's where, John, you're going to shine, is in understanding how to actually gather and aggregate those metrics. I've seen you walk customers through that portion of it time and time again. Gather all those metrics, and then work back from there. Say, okay, if you have an instance that tends to break latency beyond your SLA at 60% CPU utilization, and that's a limiting factor, I should add one more point. Find out where your bottleneck is. If it's a network bottlenecked workload, if it's memory bound, if it's CPU bound, if it's something else, if it's IO bound, if you're hitting disk a lot, figure out where your limitation, your bottleneck actually is, because that's what you're going to want to use as your proxy to scale out to start.
And I think one thing I'm thinking about right now as you're walking through this is like, okay, you're collecting all these metrics, right? You're kind of getting that baseline. You're figuring out where it's breaking, and this is helping you optimize, the horizontal scaling and understand all your dimensions and the workloads. And then that's also the same data you're going to want to be able to have at your fingertips if you are making, other changes, like changing your instance type, changing your processor family. And you could start to see like, oh, well, am I running a little bit hotter now with this new instance type? Am I running a little bit cooler? Do I need to adjust that scaling threshold? How do I make that change? I think that's one of those areas where it's just important to have all that baseline data. It's going to set you up for success if you're going to make those changes, and be more flexible to making something like an instance family or a processor family change down the road. And that's something that starts to play in when we talk about Spot and Graviton instance adoption, like knowing how this thing is going to kind of perform based on some given set of constraints, so that if I change those constraints, I will have a little bit more insight into what to sort of predict and how to turn all those knobs and dials as it happens.
Absolutely. And that's when you have all that, it's an ongoing process, right? As you know, John, right? It's not a do it once, set it and forget it. It's a constantly ongoing process. You're going to monitor your workload for any changes. It might be external changes, but also for those exact reasons. If when we roll out new instances, you want to see if they're going to be more price performant. If you've already got the data and you've already got an environment that you're testing, and you just drop one in, check the data. You're ready to go. You want to see if Spot instances can work with your workload without causing, can you handle those interruptions and still maintain your workload while saving? Great, you've got the data already. You drop in some Spot instances, see if your SLAs hold. It's exactly. You want to keep those metrics. They're going to be really critical for a lot of different reasons, but also for the ongoing process of optimization, because it's not just a once and done event.
I mentioned to you before that I like this example it's from a past reInvent 2020, and it's how Snap Inc. adopted Graviton. And they kind of show this, right, where they had this multi-architecture workload that they're running. Originally it was all x86 based, but then they wanted to introduce Graviton. They talk about, looking at some of those constraints that you mentioned and how they had to fine tune, some of the horizontal scaling. So if folks are interested in going deeper in on this and you want to see like a real world example sort of walk through in about 30 minutes or so, definitely recommend, checking this one out as a good place to start. Was going to kind of do a quick recap of some of the areas that we talked about here, because we sort of set the groundwork of, looking at compute workloads, a lot of different levers, focusing on the constraints of the workload itself. So what are those sizing constraints? And then what are the constraints of maybe the underlying infrastructure? How do we take those into account when we're doing things like vertical scaling or horizontal scaling, and understanding, how this behaves, like, what sort of happens under the hood. But the next piece that wanted us to move into, because I saw a question that came up here from someone as well, was a question saying that for scenarios where they use auto scaling for dynamic workloads, how can we optimize instance types and purchasing options like Spot to balance performance, cost efficiency, and especially consider, variable instance availability in different regions? And wasn't sure, Robert, if you think this is going to bring us into, some of the Carpenter conversations, or if you had, maybe a different take on this now. But I'm just, curious kind of where your head goes with this one.
Yeah, we can definitely, we'll be getting into containers and Carpenter, but it's a great question, and a good answer, staying in the sort of EC2 non-containerized world, would be that the usual approach is to define, if you've got aspects of your workload that are sort of steady state, whether it's a database that you need a certain amount of instances to run, or whether that you absolutely have to have this amount of instances to guarantee a certain SLA of some type. You want to stick with on demand for those instances, and then you can layer on things like savings plans. So that you spend some time right sizing, spend some time testing to get the most price performant instances you can, and then layer on some the savings plans for those instances. And then you can use Spot to burst above that. You do a mix of on-demand and Spot if you want, but how you can optimize for using that is, we have a set of Spot best practices that you got to think a little bit differently about Spot. The idea with Spot is you're using our spare capacity, and that spare capacity is going to shift around based on real, actual on-demand customer usage, as well as other Spot usage. So what's available is going to be different in real time, and pricing is dynamic. It's going to change over long term, based on trends in supply and demand. So the goal here really is just to make sure you can maintain your workload on Spot for a good price. You don't want to worry about getting just the right instance on Spot. So the way to really fine tune for performance on your Spot side of this workload is going to be, open it up to as many availability zones as you can. That gives you access to broader capacity. Open it up to as many instance types as you can, even types that don't work very well for your workload, or that you wouldn't think they're not optimized for your workload. That's okay. Even instances that have extra memory that you would never use, that's okay. This is not the on-demand world. If that instance happens to be a better price for that workload at that point in time on Spot, that's what you want. You want to get that workload per dollar down, as well as sticking to resiliency. So you want to open it up to as many instance types as you can, as many availability zones, and even as many generations. You might not want to run a really old generation on demand, because the newer generations are going to be far more price performant. But on Spot, if that one's significantly less, then at that point in time, you want your allocation strategy to select it. That's going to actually give you the better bang for your buck, essentially.
So I want to recap a couple of things there, because there's really good nuggets. The first one that I heard was, hey, if you're thinking about Spot, don't necessarily think about it as just trying to find the Spot instance for the current instance that you're running, right? You broaden your horizons and try to make sure that the workload is something that can take advantage of spare capacity, whatever instance type that might be. So look across more regions, look across more instance types, more families, take advantage of that kind of as an approach. That's really important. And then you just made you mentioned another piece at the end that I blanked on. Walk me back through that last one. 'Cause
So
even I
yeah,
missed that.
the
Yeah.
so the last piece there being, you you really want to, your goal is to be in as many different, what we call capacity pools, so that you've got availability on spot, the spot that you can find, but also you can find the lower priced spot instances that so that your workload can be as optimized as possible. And I'll even give a specific example here. This is for EC2 autoscaling, this particular dynamic workload here. We've got an allocation strategy for spot called price capacity optimized. What it does is it balances those two things. It balances selecting an instance based on lower price, as well as the depth of capacity that the pools happen to have at that point in time. So deeper that capacity pool, lower the interruption rate, the the better your spot experience, but also you're still getting a lower price. So that's how you balance, like you diversify as much as possible. You open up your workload as many pools as you can. Don't think about right sizing for spot, um, and then let that allocation strategy find the optimal price and capacity instances for the workload in real time. That's the thing. It's doing that in real time.
The piece you mentioned there around like price performance, right? Like, and looking at that's one of those ones that starts to get moves away from just comparing like rates side by side,
Yep.
like spot rate versus on demand versus CSP, compute savings plan rates. We're not looking at those anymore. We're looking at like the workload as a whole. Am I throwing more performance at this and in turn using less instances or less instance hours? Maybe the workloads are just running faster because the instances are more performant. We usually recommend looking at things like the unit cost, like a vCPU or a normalized instance hour unit cost, as a way of kind of like, hey, is this working or is this not? Is my cluster working or not? Am I getting more performance? Is the whole thing doing the same stuff for
Yep.
less net cost? I'm curious on your take on that too. Like, what are good ways for folks to kind of validate, like, hey, is this working? Is it like we talked about with the auto scaling tuning, where it's more around doing some testing and maybe using some of those metrics as a benchmark? Or do you have any other recommendations there?
Yeah, that's the main thing is you're going to want to do is, folks are going to want to track those metrics. There's a handful of tools that can help do that. So you can track spot interruptions. You can track spot pricing. We have a spot pricing API that you can call, and that's exactly right. You want to look at as the cost per unit of for your workload, whatever makes sense, whether it's transactions per second, et cetera. And you can normalize for that. Just gather those metrics and take a look at it. Hey, what is my workload costing me per user, per session, per transaction, whatever is, per job, if it's something like that. Whatever meaningful metric you have to start with, what is it costing you? And as long as your metrics can get you there, you're on the right track.
So maybe instead of just looking at like a per vCPU unit cost, you go back to that example you mentioned earlier. What's my cost per transaction or my
Yep.
cost per job, and have that data. And that might be something where got to pull in a couple different metrics, some different telemetry data, and maybe some of your billing data as well to get to that level of detail. But you can use that as like a bit of that North Star, and then dive in deeper and start tuning different aspects of this in order to kind of get to uh, validating whether it's working or not.
Absolutely. Looking at things like the per vCPU cost, those things are great for right sizing and finding out what instances are the most price performant for the workload. But once you've done that, it really is what you care about from the business side is the cost per whatever is important for that workload. So, especially when you're using spot, because then you're not using right sized instances. You're opening the door to whatever is going to be the lowest price that achieves that workload and still, hits your SLAs and things of that nature. So you might need to, when you do some testing with spot, it's possible for some workloads you might need to eliminate some instances, even though we're talking about it being instance flexible. There might be some instances that, not because of price, but just because they don't perform well enough to hit your SLAs. But as long as they can hit your SLAs, as long as they're going to work for your workload, let the allocation strategy sort of do its magic.
Cool. Um, wanted to maybe shift gears a little bit, or use that as a chance to segue into the recent Carpenter announcement. Do you mind giving like an overview of this, and maybe even a little bit of background on what Carpenter is for folks who are less familiar?
Yeah, absolutely. So let's move to the containerized world, right? That's one of the big shifts. I'll assume some familiarity with containers from the audience, but please, if not, if I need to go deeper, yell, and John will throw it in the chat, and John will let me know. But in the containerized workload, we really start looking at a application first approach to provisioning your workload. So the container, the application itself, sort of defines what it needs. Hey, I need X amount of CPU. I need Y amount of memory. Figure out. You orchestrator, figure out how to do that. And so you're defining your workload from the application standpoint. You're defining what is needed, and then the orchestration figures out how to provision best for that. So in the Kubernetes workload, we call containers pods. In the Kubernetes workload, in the ECS workload, we'll call them tasks. But the pods themselves are basically saying, hey, I need to be launched. Something saying I need to be launched. It's scale out event or a manual scaling event, and then the underlying provisioning system is going to figure out what infrastructure to launch for you. In the Kubernetes world, say you're running on something like EKS, the Amazon's Elastic Kubernetes Service. A common a tool for scaling out and provisioning is something called Cluster Autoscaler. Cluster Autoscaler will then say, oh, I've got pods that need to be placed for one reason or another. I need to launch some instances, and it'll call out to what are called node groups, which use autoscaling groups under the hood, and those will add some instances for those pods to be placed. Carpenter takes a little different approach. Carpenter was launched a few years ago, and Carpenter was said, hold on, the approach of Carpenter was looked at Cluster Autoscaler's approach and said, okay, this is great for sort of an on-demand world, but for a very dynamic, world that wants to take advantage of spot best practices, that wants to be flexible, that wants to lower the overhead of provisioning a lot of these things and configuring a lot of these things, there's a different approach. And this approach is the pods, the pods will still define what they need, but Carpenter then takes a look at your existing cluster and says, okay, can I place these pods? Well, for one, can I place them anywhere already? That's the kube scheduler will look to do that. And if not, it says, okay, in aggregate, it'll take a look at the aggregate pod requirements, and it'll find the best instance, the most right-sized instance to place those on. So Carpenter, and if it can, it'll place them on spot instances. So Carpenter is automatically looking to right size and bin pack your infrastructure. And I know I'm getting a little deep into the weeds here, and I'm going a little long with this, but one of the benefits of Carpenter that I'll just dive into is with Cluster Autoscaler, as your pods, or you're launching pods and you're scaling out and scaling in, you can often end up with underutilized instances that have a pod on them but have a bunch of compute that's just not being used, but it can't do anything about it. Carpenter is designed to bin pack, and then to, in fact, constantly optimize your cluster through something that we call consolidation. This is a feature that you can turn on or off. So it's a customized feature, but it'll actually scan your cluster, and if it sees underutilized instances or empty instances, it will actually move pods around and put them and right size your workload, in a sense. So it's constantly optimizing your workload and keeping it from being underutilized.
So I'm curious if there's a couple maybe use cases here that you could help, think about, like, hey, this is going to bring a lot of value. You mentioned one where if we've got consolidation of, our pods across the nodes, Carpenter is going to help us do that consolidation with the bin packing, so that, as things are changing within the environment, we're going to be, just running things a little bit tighter with better utilization of the underlying nodes based on all these different pods that are getting deployed out there. Anything else that this is helpful for maybe folks to sort of think about maybe some of the challenges they run into in their workloads? Like I'm thinking, would this be a helpful tool for someone who is doing something like ARM adoption with Graviton based instances? Does this help support those types of things as well?
Absolutely. So Graviton is fully supported with Carpenter. If you're looking to move to Graviton for price performance benefits, ARM support is out of the gate, and you can. There's a lot of patterns that you can use with Carpenter if you want to adopt Graviton for certain workloads and slowly migrate over. You can build out multiple node pools. Node pools are something that helps define that environment, and it's pretty straightforward to just open up a Carpenter node pool to allow for multi-arch, and then the pods themselves can select where they can be placed for that application approach. So you can start migrating your workloads over to Graviton, even in a shared service environment with Carpenter. You can easily start migrating. You can migrate one workload, and if it runs on ARM, then you can basically just use the standard labels. It's all of your usual Kubernetes labels and annotations work with Carpenter. You can use node selectors, taints and tolerations, affinities. For those who are in the Kubernetes world, you'll know what I'm mentioning here. You can use all those same ones, and then pods will be placed on Graviton instances when they need to, and on x86 otherwise. And if you've got multi-arch, you can launch on either. So you can let Carpenter select what's sort of available and best at that moment in time. Yeah,
Cool.
absolutely.
So you've got a node that is underutilized right now, and you're deploying, new pod goes on top of that. It'll take advantage of, the low utilized or underutilized, node that's already out there. You just drop it on there using whatever the appropriate, architecture is for
Hmm.
whatever that base image is,
Yep.
without having to say, hey, you got to manually do all this and kind of broker it and handle that all on your own, right?
Yeah, as long as you've got a multi-arch image set up, so a little bit of work for that. You've got to be deploying that particular workload to in a multi-arch environment. So there might be some additions to your CI/CD pipeline. But as long as you have a multi-arch image and then your manifest points to both of those, yeah, it absolutely Carpenter will grab whichever one it needs. If it's got to your point, John, that was a really good point. If you've got an underutilized x86 instance, but you've got a workload, that a pod that needs to be launched that normally would run on Graviton, well, it's going to be more optimized if you can place that thing on that underutilized x86, and that's exactly what Carpenter would do in that case.
And then the other one is true too, where if you've got a bunch of x86 workloads that are running, that stuff's all out there, and then you want to deploy something that's ARM based. Carpenter will go through and actually grab ARM based Graviton instance. It'll spin that up as a new node, and then it'll drop your Graviton or ARM supported image for the pod right on top of that. Right? Is that
Yep,
cool?
absolutely.
Cool. So yeah, so we're talking about all these different cost levers here, and things like Spot, things like Graviton versus x86, and if we're able to take advantage of using Carpenter, we can kind of have a lot of that overhead that normally would be doing kind of managing separate environments, and just have this do a lot of the heavy lifting for us, right?
Hmm.
And
Exactly.
so which environments would folks be able to use Carpenter in now today?
So any environment, any Kubernetes environment, really, you can use Carpenter. Even if you're self managing your Kubernetes environment, Carpenter is just deployed as a Helm chart, so you can you can run it in a self-managed Kubernetes environment. If you're running on EKS, again, it's just very easy to launch Carpenter. So it really, any Kubernetes environment, you can look to leverage Carpenter, and there's really no sort of type of environment where you could not run with Carpenter. It's used in a lot of customers who have a shared service platforms, a containerized shared service platform. So it's something that's great to use all around.
Cool. And I see a question that came through
Hmm.
here. What types of tools and metrics are you looking at to tune scaling with Carpenter to reduce pod underutilization?
So great question. There's for the most part, you can use all of the good tools that you're used to if you're already in the Kubernetes world. Some of the tools that I like personally, so there's kubeops view, which is a common tool that is just a good way to visualize your cluster. Now that's not necessarily metrics and logging, but that's a good way to just sort of see what your cluster is looking at. And sometimes being able to visualize things, it helps orient yourself. There's a handful of other tools for just logging things. You can use, there's certain sidecars. There's sorry, I mentioned kubeops views. There's I'm blanking on the name. John, you might actually know the cubes cost, I think, is a
Oh
common
yeah.
one.
Oh yeah. Cube cost, open cost, a couple different options out there for taking a look and kind of pulling a lot of the data straight from EKS and giving you cost transparency directly on top of
Yep.
that and layering that in. So all those things are so cool too for getting more cost visibility. And there's different levels of this, that we see with customers as well. It can be surprising, even, we always talk about the CUR data and being able to even get back down to that. Robert and I recently were working with a customer on looking at some of the trends with cost changes from introducing in new components here. And we were even just using EKS cost allocation tags. This is a feature that came out back at the end of 2022 that lets you look at the CUR data and view EKS cluster level costs just natively in the CUR. So it'll basically take the cluster name and pass that through as a cost allocation tag. And then you can look at that in time series over, hourly detail down to hourly grain, and maybe see some of those patterns where if you've implemented some fine tuning in one cluster, not the other, you can see kind of how those are comparing. So a lot of cool stuff out there that may be accessible just from how folks are already looking at some of their cost and usage data today. And got a question in here too. Is this video recorded? It is. This video will be up on YouTube. I think as soon as the start of next week. So yeah, make sure you check in and check the YouTube channel. I'm going to drop that link in here that we've got as well. I was hoping, Robert, and we've got maybe a couple minutes left here. We were talking about some of the other new things that have come out, and you mentioned around things like the new X8G Graviton instances, the CAG, M8G. Do you mind giving a quick overview on new stuff that's come out in the Graviton world? Because there's a lot that's coming out pretty quick.
There's a lot. So yeah, I'll make this real quick. In the recent sort of weeks, months at most, we have released our Graviton 4, our 4th generation. In mid-July, we launched the R8G. But yeah, in the last few weeks or so, we've released the X8G, the C8G, and the M8G instances. So the Graviton 4 is our 4th generation of Graviton. Some great things about Graviton 4 is extremely price performant. We've actually increased the size that you can go with Graviton 4. You can go up to a 24XL a single socket, and this is the first time for Graviton we've launched coherent multi-socket. You can go up to 48XL. So it's going to be great for really big databases as well as other workloads. We've got so staggering amount of cores and memory on these things. We beefed up the memory speed as well. Increased the layer 2 cache for those who want to get into the architectural side of things. It's just a beast of a Graviton generation, and I'm pretty excited about these new. And these are rolled out. They're available right now in a few of our regions. So definitely, this is something to start taking advantage of.
That's really cool. Yeah, we've heard that from a lot of folks that were saying, "Hey, I got this big x86 workload. We're running on a 24XL. We want core parity with a Graviton equivalent, or something that's got the same vCPU allocation there." And now they have it, right? Which is really cool. Those are going to open up a lot more workloads to be able to shift over to Graviton without having to make a lot of changes to anything, or modifications to what the underlying core requirement is for it. So that's super exciting. And I think a lot of folks don't even realize that we're at that 4th generation for Graviton now, which is really cool too. So if you're already running a Graviton workload, it's a great way to evaluate these new instance types and see what types of performance you get. If you've got, compute intensive workloads, or if you're looking for, good reason to evaluate, Graviton, take advantage of some of these new options, that are available out there too. It's really cool, and not even at reInvent yet. So I know there's going to be a lot of exciting announcements coming then as well.
Yeah, I'm looking forward to that.
I'm wondering, we got a couple minutes left here. We got about 5 minutes. You mentioned a customer case study before, and not sure if that's one that you can give a little bit of detail on, this like PickPay case study that you mentioned. Maybe just like what's worth diving into on this one. What might be of interest for folks out there.
Yeah, I think this case study is going to be really great. So it's going to tie into the question you asked in the beginning, right? Where you asked folks, are they looking beyond right sizing for optimization? And there was a few, but many of you, we're focused on right sizing. So this is going to be a great case study for you to take a look at. I want to tease the benefits of looking outside of right sizing for cost optimization here. All of them, from Elasticity to Spot to Graviton. So PickPay is a Brazilian financial services company, and they went to modernize their infrastructure. In 2022, they started a modernization effort. So they were running self-hosted Kubernetes. They serve something like 60. They have 60 million customers, and I think it's 35 million active users. So they're big. They're serving a lot. They shifted to EKS, allowing us to manage the control plane of their environment. They adopted Carpenter for all of the Elasticity best practices that Carpenter brings: consolidation, in fact, spot to spot consolidation, which was something new, rolled out as well somewhat recently. They adopted some spot instances for 100% of their non-prod workloads, and I believe that roughly 40% of their production workloads they had on spot. And then they've started to adopt Graviton as well for roughly, I think, 10% of their workloads. So adding all those things together, they ended up saving over 50% of their monthly spend. So, I mean, how many of you out there would like, if I asked you, would you like to cut your AWS bill in half, would raise your hands, right? That's the power of elasticity, of efficiency, leveraging Spot, leveraging Graviton. And it's an ongoing process. They're probably going to be able to optimize more. They're going to look to increase their Spot usage to 70%, and they're going to continue their modernization journey on to more Graviton for its price performance capabilities. So I absolutely encourage folks to take a look at that case study. And if that's not a good teaser for looking beyond just right sizing for your efficiency for your workloads, that I don't know what is.
I mean, I'm sold. So that's that is a really cool example. So for the folks that listen to this, they're excited now. What's a good next step for them? What's something that maybe can help them identify some workloads, get more familiar with this. Any recommendations there?
Yeah, we've got a few tools that I don't think we have links for, but we do have some open source tools. There's something called the Flexibility Score Dashboard. If you were to Google that, it's on GitHub. You can deploy that in your environment, and it gives you a score of sort of scaling across different ASGs, instance flexibility. So it gives you an idea of where you're at and what kind of workloads you can maybe dive into. If you're running any kind of containerized workloads, start looking at Carpenter. Awesome, John. Quick on the keyboard there.
Trying my best. That is a great one, because then if you're looking at a big org and you want to get more insight, into what are the workloads to focus on. I think that example you gave is a really cool one, where you could have a workload that's already elastic. It's already, doing some stuff. Could you add in, Spot instances of that? Could you add in, Graviton, take advantage of maybe instance flexibility in something that's already very elastic, or find the ones that are inelastic, and maybe that's where you want to zero in and look at introducing in the elasticity. So really cool on that one. And I'm going to try to search for whatever else you're going to mention here, Robert. So let me know.
We'll make it quick. Well, the other thing I would mention, it doesn't require a search, is reach out to your account team. They're going to be a great source of if you've got an account team, reach out to your account team. we can help out. We love to help out. So, that's always a resource for use. Um, and if anything, that's a great place to start. Is we're happy to help out.
And Robert's been kind of the compute efficiency Sherpa, like guiding everyone through all these new levers. And I've learned a ton from you walking through, some of the workshops and some of the labs. So I was going to give a plug to this one as well. There's a ton of workshops and labs that are out there that folks can just run through on their own. If you're not familiar with something, you want to learn more about it and just get like an extra level of knowledge in it. Take advantage of some of these ones that are out there, and just spend a lunch break or something going through and trying your hand at using some of this technology and understanding it. And I think those are great ways to sort of like get yourself excited about this stuff and get a little bit more hands-on, maybe understand how some of these pieces work a bit more.
Yeah.
But just one example, I mean, the Spot workshop, is another great one. Graviton workshop, the Carpenter one that we've got up on the screen here. I learned so much from those, and from you, Robert. Hope folks can take a pass at doing those themselves as well. Well, awesome. Wanted to say thanks for sharing all this awesome knowledge. We're going to put all these links and this recording up on the YouTube channel that we shared over here as well. So make sure that you subscribe to this and check out the content. Just like Robert said, reach out to your account teams. Dig into some of the content that we have, and reach out to us and let us know, what you learn, as you start to dive into some of these new optimization levers. And we're excited to hear about the results. So thanks again, Robert. And we'll see everybody next week.
Yeah. Thanks for having me on.
All right.